Yeah. Good morning. How are you? I can't be depressed. Okay, so let us pray first. Heavenly Father, we thank you for this day. We pray for the God for understanding in Jesus' name. Amen. Okay, so this is QSN4. QSN4 roof structure, page 70. Let's start from page 70. Okay. So on page 70, it says example 4.4. The figures on the next page show the roof plan and section of a cottage house not to scale. Specifications. Timber for trusses, 38 by 114. Trusses spaced at 750 millimeter centers, 114 by 39 wall plate, 52 by 76 millimeter sawn pair lines, 76 by 76 wrought if pair lines. The pair lines, we have two different types. We have just pair lines again, then we have wrought if pair line. A wrought if pair line, it is found at the eaves. Eaves is somewhere more where there's an overhang. Get the last one, and it's usually bigger than the pair lines that are here. I get more, you will have pair lines, and then more on top of your covering. It's usually 3 pair lines, right? Okay, and then Ramali and Eve's pair line there. So more, they are telling us that the sun pair lines is 52 by 76, but the rod if pair lines is 76 by 76. Rod if giving the one at the end, again. Okay, and then we have 600 millimeter overhang at eaves. This is your 600. When they talk about an overhang, if you can go outside the class again, you will see what okay, this is where my wall ends, but this is not where the roof ends. Roof, it ends somewhere. Let's say it's like this. So from here up until where your roof ends, that is called an overhang. Again, it's the same as this one. From where your wall is until where your roof covering ends, that's called an overhang. Okay, and then we have 100 millimeter overhang at gable end. So here they're talking about two overhangs. Renali overhang at eaves. At eaves, you look at this structure. Again, at eaves is the one where we'll be talking about the roof between the wall and the roof. And then the overhang at gable ends, you look at this structure. Gable ends, they're talking about this part. This is your gable ends. Again, so more. That is your overhang. They're saying it's 100 again. So 100 millimeter overhang at gable ends, 600 millimeter overhang at eaves. Okay, and then fiber cement roof sheet roof covering, fiber cement rich piece, 15 by 200 cement fiber cement fascia board. So fascia board, I'm not good with 3D drawings, but. Wait. 3D couple, you just. So this is our roof again, and then let's say it's like this. On this part, I get a gable roof. It's like this. Cap triangle is those ones that are like this again. So there will be something like this, yeah, something like this at your roof again. So there will be something like this. So this something like this, key badge board. It's called a badge board. Okay, this is called a badge board. And then we have a fascia board. A fascia board is the one where it is on the straight part. When you check, okay, how can I put it? Okay, yeah. So this is how our house looks like again. So this part more imaginary a gable. You saw it's a triangle. So more, this is the long side of your house. Again, on this long side of your house, or on the roof, there is a straight liplanganyana thing. Okay. So that thing that is there, it's called the fascia board. Fascia board is straight, it's on the roof. And then on your gable, like I said, you imagine this part is a triangle. On your gable here, on the sides, we call it a bashboard. So fascia board is straight, but bashboard are straight, okay? And then roof pitch 30 degrees, brick wall 220 thick and face externally. Our brick wall, they're telling us that it is 220. More on this diagram, okay, that's fine. But if this is a gable and this bigger part that you see here is the wall, okay? So it means for your wall is 220. I guess they told us that it's 220. And then they say draw to scale. Half the roof truss and measure the roof, including all other labor and material above the wall plate. So here, they did not do this for us. They didn't draw this half a truss for us. Again, we were required to do it. The only thing that they gave us was this structure and also this structure. And then they want us to do this. So there is a way that we can do this again, but we'll do it some other day. Right now, we'll just use the sketch that they gave us again. So here's our sketch. We have drawn again. That's the one that we'll be using. So, prepare something to erase. Okay, so now we're going to start. This is our half class we're going to start now. And then there is a checklist. The checklist, tell me the checklist there. What's the first thing? Check out, I'll give you the checklist. Get it? The wall again. And then the finishes. I'll do it. On the wall, you need to say gable. Like the wall that you're doing is gable. It's the wall, then it says gable again. Our wall is gable, and then the finishes after beam filling, after the wall plate, yes, the trusses, yes. If I let roof tiles, can why will it be called? Hairlines, yes. Covering. Ridging. Like this. Okay, and then the fascia and badge board. I just showed you what fascia board is and what a badge board is again. And then garter, downpipe. You find it? Okay, so this is our checklist. It's the gable, the finishes, the beam filling, the wall plate. Okay, you get beam filling, then the wall plate. After wall plate, it's what? The trusses. Then the roof tiles, then the pennant, the covering, the ridging, the fascia and dashboard, the gutter, the downpipe. So that's our checklist again. And then let us start. The first thing that we're going to take off is what? The gable wall, like it's the wall. So you're going to do a dimension paper. Dimension paper has 3 small lines, 1, 2, 3. Then a bigger one, like that. So you're going to open a bracket here. When you open your bracket, I'm not going to be writing full descriptions, I guess. Yeah, you will check from past papers, but okay, if it's a gable wall, this is the description, I guess. So this is a gable wall, and then here, method 1 brick wall. So in a gable wall is like this. It's those kind of houses that the structures like this. Again, these days where we have what are called butterfly roofing, what. But here we're focusing on the gable roof. Okay, so a gable roof is something like this. It's shaped like a triangle there at the top. So a gable roof, a gable wall, it consists of 2 shapes. It has shape A and then shape B. Shape B is called a rectangle. Shape A is called a triangle. So we have a triangle, we also have a rectangle, again. A triangle and then also a rectangle. So when you do a gable wall, you're going to take off both parts, the triangle and also the rectangle. So you need to know that where does your gable wall start? So let's say we have a height here, our height, just for an example, our height is 2000 and then our rectangle there, it is 250. If we were to take off the gable wall, what you would do, again you need to separate these two shapes because the formulas are not the same. You can't put them inside one thing and again calculate them all together. You need to calculate them separately. So triangle. If you wanted the height of the triangle, you will take 2000. 2000 here is the height of the gable wall. It's the height of the whole thing. Again, then you will subtract 250 for the rectangle, then you get the height for the triangle. But for the base, if your base here is 3000, the base of your rectangle, the base of your triangle will also be 3000. The triangle is sitting on top of the rectangle, so the height is there, the base is the same, the width is the same. Okay. And then now, we'll start with the triangle. Can just draw a shape there to indicate that this one is a triangle. So we know that a triangle, the area of a triangle is half base times height, right? So this is half base times height. You don't write this here. I'm just showing you that it's half base times height. So what is our base of the triangle? You come and check this diagram here. And then when you check this diagram, we are going to check, okay, here we have 145, we have 1270. You need to know where your gable wall starts. A gable wall starts under the wall plate, okay? Under the wall plate. So which height are the wall plate between 145 and 1270? So it means that 1270 is the height of our gable wall, okay? And a gable wall, we said, is a triangle and also a rectangle. So it means from here to there you have 1270. Let's check the height of the triangle of the rectangle. And then if you can check, we have from here to here, 195. So from here to from under the wall plate up until this corner here, this corner is 195. And then this part is external. Then you have an internal height which is 257. It's okay, it's like this. Your wall is like this, okay? The one at the corner, the first corner, this one, it is 195. That is your height of your rectangle, okay? That is your height of your rectangle. The external one, you take the external one, the one that ends at this corner, this first corner, not the one where it's sloping, okay? So it's 195, so it means that this is 195. And then the 257, you will see where we are going to use it, okay? So you just know it like that. Or no, my rectangle it starts under the wall plate until that first corner. I don't take that one, or it has a long line like that, okay? So, okay, we have 195, we have 1270. This is A, this is B. We want the height for A. How are we going to do it? Height for the gable wall, which is 1270. Then what do we subtract? The height for the rectangle, which is 195. And what are we getting? A? We are getting 1075. So it means that the height from here up until there, it is 1075. Do you understand? Yeah. Okay. So now we come here to take off. On the takeoff part, you're going to say my base. Remember, the format here to write is length, width, and height. We don't have the length, we have a width. Our width is, what is our width here? We have 3732. Like what 3732 here? This 3732, it is the base of your gable wall. How do we know that it's the base of the gable wall? I get a gable here. This is a gable wall. This is where your wall ends. So that is the width of your gable wall. Here, this is your gable. I get gable wall here. So where it ends, get that 3732. Or you can say, I have 1866. Did it draw well? 1866 here. Does it start here? Check on the diagram. Yeah. It starts at the end. Eh? Yeah. Okay. So you can say 1866. Remember that this one is for a half truss again. If you want a full truss, what do? 1866, you multiply it by 2 again. So let's calculate what are we getting when we multiply it by 2. What is 1866 times 2? 3732 again. So it's still the same answer. So you just take this. This is your width. Or you say, oh, I have 1866 there. I get it. You are looking for the width of your gable wall. This is your gable wall. This is where it starts. And remember, this is just the half truss. There is also the other part again. So from corner to corner, it's not the same from corner to corner. It's the same thing. Like, so whether you take 3732 or you decide to say, oh, it's 1866 times 2, it's fine. Okay? But for you to understand, at least you know both ways. You go, oh, I forgot which one to do. So let me try 1866. If it gives me the same route here. So our length, we don't have it. Our width is 3732. Each and every time when you want to write here, what do? You divide by 1000 again. So what is 3732 divided by 1000? I have no idea what it is. It's fine, let's continue. So directly you put 3732 divided by 1000 in 3,73. So it's 3,73. 3,73. And then our height is 1075. 1075 divided by 1000. 1,08. Again, you will round it off, so it's 1,08. And then the formula for a triangle is half, for the area for a triangle is half base times height. Again, so here you've written your base, you've written your height, then you're going to say half. So it's half base times height, half base times height. And then we are not done. What's your time? What's your rectangle? Push it on the side again. We need to multiply here by 2. Why are we multiplying by 2? Hmm? Why are we multiplying by 2? Okay, let us check. This 3732 again, it is for the whole gable, right? Let's say it is that side. I gotta remember. This side is okay. This is our house again. At the front, we have a gable wall. At the back, we have a gable wall. So this 3732 and this height of 1,08, it's only for that side. It's only for the front again. So if we turn around, we go to the other side. There is also a gable wall that side. So it's 2 gable walls in one house. Do you understand? at the front and at the back. This two, I said to you, this is a half truss. No. And this two, it's not two, this is a half truss. I get when you took off 3,73. So why are you saying it's a half truss? Like one again. This two is for the front and also at the back. You have a gable at the front, you have a gable at the back. Do you understand? Yeah. Then we underline, we go to the rectangle. So rectangle is breadth times depth or length times depth. Length times breadth again. So our rectangle, I said the base of the triangle is the same base as the rectangle. I get a triangle is on top of a rectangle, or a rectangle is at the bottom of a triangle. So it's the same. This is where your rectangle starts. This is exactly where your triangle starts. So it's the same again. So this is also 3,73. I'll show you 3,73 or 1,866 times 2. So that is how we do it. And then our height for the rectangle is 195, which is 195 divided by 1,000? 0.20. It's going to be rounded off to 200 again. Then we multiply, we underline. Do we multiply this one? Yes. Again, if you multiply the triangle, you are saying you have a triangle at the front and at the back. And remember, your rectangle is at the bottom of your triangle. You multiply it by 2 again. Okay, did you understand? Okay, so now we move. Again, this is inside one bracket, this is a gable wall. Again, you extend the line, then you close it. You can't say, you can't do this. You don't know where your information is going to end up. Again, what if you are you going to erase this? So what you do, you just make a corner there. To remind you, you need to make a bracket. Again, if you don't, you might forget. So just make something like this. You write, wherever it will end, what did I solve? Do you understand? Okay, so now we go to raking and cutting. Raking and cutting. So raking and cutting, we're talking about a gable wall. Again, raking and cutting is cutting off the bricks on your gable wall. Let us check. If we have something like this, remember our gable wall is like that. Again, so if you have something like this, a 220 wall, you can't do more. It won't. A 220 wall will not fit in here. So they will cut, especially this part, right? At the corners, they'll have to cut the bricks so that they will be able to fit here again. So a full brick will not be able to fit there. Even when you want to brick, like what I cut so that it will be able to align with that triangle again. So raking and cutting, we're talking about the cutting of bricks on the gable wall. Okay, so raking and cutting, you look at, we have 2159 there, we have 2924. How do we know which one is our height of raking and cutting? It can't be 2924, right? Reason being, raking and cutting, again it happens on the wall. There is no wall here. Again, this 2924, this is where it is ending up at. Again, this empty space more, there is no wall. Raking and cutting happens where on the wall. It means where your wall ends. No more raking and cutting will happen again. So that's how we know which one to choose between 2924 and 2159 again. So that's our height of raking and cutting. 2159. So it's 2159. So 2159, when we take it off here about 2 comma 2,16. Again, we have about 160. Then we divide it by 1,000 again. So it's 2,16. And then let us check something. Let us check something here. Remember, this is a half class again. This is a half class. When this is a half class, this 2,159, it is only for one side. And when it is only for this part again. But a gable wall, even this side again. So now even here, it's 2,159. This is only for the front part. It's like this. This part is 2,159. This part is also 2,159 again. So it means that this 2,159 will be multiplied by what? By 2 for let's say it's the left and also the right again. You multiply it by 2 again because this one is only for the front part. There is also the back part again. Yes. So you multiply by 2 again. Do you understand? Alright, then next we go to the beam filling. We go to the beam filling. Let us please go to page 70 at the top. The information there states that beam filling is half brick wall built from under the wall plate. Beam filling, let us check this diagram. The same beam filling is half of the wall. This is your wall, it's a 220 wall again. So half of the wall, the half here of your wall again. So it's from here up until there. Where does it start? Under the wall plate. So it means that it starts at the very same position as the wall plate. Like a wall plate, and also your beam filling, you tell mama where your wall plate starts again. Your beam filling, it is this space that you see here, this empty space that you see there, that's your beam filling again. So your beam filling is from under the wall plate and it also takes half of the wall. Let's continue. The beam filling is a half brick wall built from under the wall plate up to under the roof covering. It closes the gap between the end of superstructure, wall and the roof covering caused by the rafters and purlines of the batten. So there's our beam filling. So now we want to take off our beam filling. The height of our beam filling, what is it going to be? Is it going to be 195 or 257? 257. It's going to be 257 again. I just explained now where does it start? Under the wall plate again. And then get this space that you see here, this one here, up until, okay, let me draw it. Remember we said the 195, the rectangle part for the gable wall, you take it from under the wall plate until the first corner again. Then for your beam filling, it starts exactly at this very same point, up until it surpasses this one again. It will pass this one, so it's from here up until there, which is 257. So beam filling is you take the internal one. I got 257, it's internal, but 195 is external. So what you take for the gable wall again, you take the external, but for the beam filling, you take what? The internal again. The internal one cannot be 257. It starts where? Under the wall plate until the top corner. Okay, what we can say, how we can put it next, we can say our beam filling, it takes half of the brick, it starts under the wall plate, and it is also the internal height, not the external again. So it's 257, and as you can see there, the one next to the pay lines. So I get more on the pay lines, there will be pay lines here, there will be pay lines there, so we can say the one next to the pay line. So where are we? Okay, that side. So the height of our beam filling, we have concluded that it's 257. Again, 257 is 0, 257. Again, it will be 260. 257. You know what 260 again? 0,26. Again, if you divide by 1,000, 0,26. Remember here it's length, width, then height. The 0,26 is our height again. And then what is our length? Do we have a length? For the beam filling, do we have a length? Beam filling, the first thing that you need to ask yourself, is it internal or is it external? internal again. Okay, so here we have 6440. Let us look at this structure. We have 6440. This 6440 is starting there at the bottom, and it is including the gable end again, but at the top it's not including the gable end. So you have 6440 there, and you want internal. Internal means that you don't include the walls. If you say something is internal on the leg, you don't include the walls. Again, so 6440, what we want, it's from here up until there, excluding the walls. So it's going to be 6440 minus 100. Move fast again. It's not going to be 2 of 100 because this 6440 is not including the top 100. Okay, it's just 100. So the length is 6440 minus 100 for the bottom gable end. And then minus 220 at the bottom, minus 220 at the top again. And you want from here until there. So it's 6440 minus 100 minus 2 of 220. What is the answer? Mm-hmm. 5900. Do you understand what we did? Yeah? What is it that you don't understand? Do you have a question? Beam filling, I can you said it's internal. Internal means that you don't include the walls. I get it, this is your wall, this is the wall. I get. So we start from here where there is no wall, up until there where there is no wall. But this 6440 more fast, see into the gable and this one here 100. I get from here to here 100. That is why I don't teach 100. Here 1 because at the top 6440 I included that 100. So you subtract 100 more, you subtract 220 more, you subtract 220 at the top. What is it that you don't understand? You shop now. Would you shop? So it's 5,900. It's 5 comma 5,90. It's only the length and height, okay? So you underline. So I have a question. Are we going to multiply our beam filling by 2? No, we don't multiply it by 2. Why do we multiply by 2? We don't again. We are going to multiply our beam filling by 2. Reason being, remember what this is only for this side again. There is also the other side. And beam filling, it takes the longest part. Again, as you can see here, we have 3732. Here we have 6440. Beam filling, you do on the longest part, only on the length, not on the width again. So we're not going to multiply it maybe by 2 of 2. No, it's only by 2 because it's on the left and also on the right again. Yes. So you multiply this by 2. Do you understand? And then what's next? Another question? Okay, so now we have beam filling. We took off beam filling again. We have what is called facings on beam filling. Facings is the part that you are able to see again. So let's just say we are doing a superstructure and we say we have facings. If we are outside, we are going to take off the whole entire wall again. But if we are inside and we talk about facings, we won't include what is behind the skirting because we can't see behind the skirting. So facings is what you can see. Okay. So now this 257, we can't see everything on this 257. Again, we can't. We are not able to see this part. This one where the upper lines, we can't. The only part that we are able to see is this 195 up until this corner, up until the one here again at the corner. So facings on beam filling, faces on beam filling. What is the length going to be? It's the same as the beam filling. I get your beam filling length is 6,000. So facing from your beam filling is 6,000. Oh, 5,900. I get 5,900. So the length is 5,90. It's the same thing. And then what is our height going to be? Height of the facings on beam filling, what is it going to be? 0,20. We're going to take this 195 again. Yes. So it's 0,20. Then you underline. Are we going to multiply this by 2? Yeah? Yes. What? Yeah? Your side. Which side? This one? This one? Huh? This side? Hey, yeah. You can't even feel it. More. More. Huh?
Your question is very tricky.
It's tricky. No, I can always say the beam filling, it stays on this long part.
Yes.
On this long part. So I'm asking, I think you are saying on the side. When I did not specify, you just said on the side. This is the side too. So I'm asking now, is it this part now? Yes. With this is the width. Beam filling is not on the width. So is it this side? This side?
Yeah.
No, when I say this side, I'm not saying for external or internal. I'm just saying for this side. Yes, it's for what? This side. Okay. So we need to multiply by 2 because it's this side and also that side again. Right. And then now we move. This is still inside a bracket. So we've done the facings on the beam filling. Now we're going to the wall plate. Wall plate is that erase more. Have you understood everything so far? Another question? Okay, so we are going to the wall plate. The wall plate. What do you know about wall plate? What is it that you know about wall plate? What's a wall plate or where does it stay? Internal. Okay, another one. What do you know about a wall plate? What do you know about a wall plate? Look, one plate is this one, and then beam filling we said is the other one. So where there is a beam filling, there is a wall plate on the other side again. I get a beam filling takes half, wall plate takes half. So when there's a wall plate, there's a beam filling. And the same length of the beam filling is the same as the wall plate, or the length of the wall plate is the same as the beam filling. I guess they stay at the same place. Yeah, half. So leave wall plate in your is going to stay where? Here. You don't include the walls again. Again, as you can see, the diagram, so you have the wall plate there, then you have the beam filling. So you don't have to calculate the length again. You just say, no, I calculated this in beam filling, and I know what they share the same length again. Because if this is a 220 wall, your beam filling will stay here, your wall plate will stay there. Again? Okay, so what is the length of our wall plate? But for you to not be confused when you are doing your notes, let us just calculate again, okay? So we have 6,440, then what do we subtract? Let's look at the diagram. What do we subtract?
100.
100, which one? The top one or the bottom one?
The bottom one.
So minus 100 and then
Minus 2 of 220.
minus 2 of 220. And what do we get? 5,900. This is 5,90. Okay? So, whole plate, are we going to multiply it by 2? Why?
Even people will carry into sign
Okay. And then another thing that can link you again, and this is a full roof again. This is your wall plate on the other side. Also on the other side, there is a wall plate again. So you multiply this by 2. And then remember that wall plate, it's a team again. It's a plank. So plank, just like this wooden table again, it is painted with its own paint. It's not the same paint as the one they use on the wall again. They use oil. So it's pre-treated with carbolinium oil. So if it is pre-treated, did they mention pre-treated on the specification? Or they just said the wall plate? They said 114 by 39 wall plate. They did not talk about the treatment again. Okay, but we know that it has to be treated. So let us include it. So it's 5,90. And then what I want to know from you is that wall plate, lay the treatment to the wall plate. They're going to be separated. Again, they're going to be separated. What I want to know from you is that are we going to calculate the perimeter here on the wall plate or on the treatment of the wall plate? Again, this is a wall plate. They said our wall plate is 114 by 39. When I say perimeter, I mean that all the sides. Again, there's that formula that says 2 of 114 plus 2 of 39. So do we do this here on the wall plate or on the treatment? On the treatment. Again, wall plate is measured in meters. So you underline like that. Again, it's measured in meters. Okay, so now you close this bracket, you open another one. Then you say this is a treatment wall plate. This is treatment to the wall plate. So if this is treatment to the wall plate, we are going to use, this is square meters. It has a length and also the perimeter. So our length is 5,90. You multiply that by 2, then you calculate perimeter, which is 2L plus 2B. This 2L and 2B that we are calculating, remember this is the wall plate again, and we are saying it needs to be treated. When we say it needs to be treated, we are talking about the paint, the oil again. It has to be all this side, and also this side, all the sides again. So that is why we are calculating the perimeter. We are calculating the perimeter so that we know what amount of paint are they going to need again, because they are going to paint all the sides. So length here right now is 114 and then plus 2 of our width is 39. So what is our answer? 306. So this is 0, this is 0,31. How is it 0,31? It's 310. 036. What did you do? It's 0,31. Hey, I want to know what this 306, did you round up and get 310 now? Yes. So 310 divided by 1000 is 0,31. Yes. Okay, we underline. Are we okay? Okay. One plate is measured in meters. So it's just the length. Then you square it because it's found on both sides. Then the treatment to one plate, you need to calculate the perimeter because you need to know which amount of oil is needed again. So they paint all the sides. So this is how we do it. Okay, erase. Yeah. Okay, so now we're going to the pay lines. Pay lines, as I said, Herumana specification, we saw that there are 2 pay lines again. There are the start pay lines, which are the ones on the roof, 1, 2, 3. Then we have an if pay line, and if pay line is this one at the very, very, very end of the covering, okay? So our pay lines, on your description, description, make sure that you write the size. I get that they're not the same. So this one, the hair line is it 52 by 76? Please confirm on the specification. 52 by 76. Okay. So hair lines. Let us check this diagram. Let us look at the top diagram. Hair lines. Like whenever they're seated on top of the roof. So if they're seated on top of the roof, they can't be internal. They are external. Okay. So if they're external, let's see something. Internal means referral, right? But if you can check your pay lines, this is where they end up. So if you're external again, so it means that it takes the entire dimension again. So it's going to be 6440 plus 6440 plus 100. Lisha? What's going to be the length of our pay lines? Our pay lines are external. Line one of our wood is external. Plus 1200 wood 6440 plus why would that?
Oh, that's it.
Eh?
Sorry. I was not focused.
Why were you not focused?
I was busy drawing dimensions here, but plus 100.
6440, 6448 starts at the bottom.
Yes.
And then plus 1200. Yeah? So you know, so it's only 100 again. I get that this one is 6440 is already included the 100 at the bottom. So it's 6440 plus 100 here you are. What's the answer? 6540. Pay lines are external. Pay lines are external. You look at your diagram. Why one and you're like speaking to you? No, me, I'm external. Okay. So it's 6,54. Okay. So if it's 6,54, you count how many pay lines you have. Okay. On the diagram, they did not draw the pay lines for us. But if you can check superstructure diagrams for superstructure, diagrams for plain opening again, they also show a roof structure. You will see that they usually have 3 pay lines here again. So you need to know that 3 pay lines is the standard. Even if here, Bona, just because here there is nothing, does not mean for it, there are no pay lines. Pay lines have to be there. Again, does not mean for there are no pay lines. You just need to know for it. Pay lines, get 3. Again, it's always 3. That's a standard. So you multiply here by 3. Get 3 pay lines again. Then you multiply by 2. This 2 that you're going to multiply with again, it's because 1, 2, 3 pay lines again. Also on the other side, it's 1, 2, 3 pay lines. So it's 3 per side again. Remember, this is the full class. So you're not going to say multiply by 2, multiply by 2. It's only multiplied by 2a1. Again, you are saying, I have 3 pay lines this side. I also have 3 pay lines the other side. You understand? Yeah. Okay. Are we done?
Yes.
Do you understand? Matu? Right? Got 3. Key number of pay lines. The pay lines get 3. 1, 2, 3. How do you go on? I just explained for you. Okay. On this diagram again, they did not show us the pay lines for Kicheka. But if you go to the textbook, just page or check up example of superstructure or plain opening. Again, whenever for this kind of diagram, you will see on top 3 pay lines. So it's always 3. Even if I know when I will get 3, it's a standard get 3 again. Okay, so 3 is the number of pay lines. Number of pay lines. So 3 is only one side. So multiply ka 2 or again. Okay, next. The calculator. If's pay lines. Here we only did the pay lines again. So if's pay line. So you close the bracket, then you go to the if's pay line. What's the size of the if's pay line? 76 by 76. If's pay line, is it external or internal? External. The pay line is external. Again, they're on the roof. Everything that's on the roof is external. So this is also 6,54. And then the pay line, the if's pay line, it's only one here at this side. Again, the other side, so here you're going to multiply by 2. What is this 2 for? 1 multiplied by 2 again. So that 1 is unnecessary. So we just say 2 again. This is more like saying I have 1 per line and then 2 sides. I get 1 per line this side and 1 per line the other side. So it's like this. So we just say 2 there. I get eternally king post. King post it's only 1, but we don't say 1 times mama again. Yeah. So this is how we do it, and then are we done? What's left? The trusses. Do you have any questions? Lishap? It is still recording mode.
Yes.
Yeah? Okay, and then now we're going to the trusses. Trusses. Timber, they're made of timber. Let us go to the information about trusses before we can continue. Let's check a page where they're talking about trusses. Page 68. Page 68, are we all there? Okay. Trusses. The construction of roof trusses varies. Some have members nailed together, others are bolted or gang nailed. This information is in N5 and 6. Again, this one here, some are nailed, some are bolted, some are gang nailed. So all the truss members are measured in meters to net length with no allowance for splay cards, and the length are categorized. When they say length are categorized, it's more like on the ID, I get gender is categorized. Like at the female there is male. Let's say in a class where let females stay that side, let males stay that side. I get so it's the same. They were categorized, but they categorize us. I get if we are white that side, black that side. That's categorizing. Okay. So let this ones. The trusses charina, they are categorized again. The trusses they don't exceed 2,4. Let's say this is a truss. A truss is not like this, but just making an example. Okay. Let's say this is a truss, but this one is not exceeding 2,4. Okay. It means that all the trusses that are not exceeding 2,4, they will fall under one bracket. Okay. There are trusses that exceed 2,4. Now they'll be categorized. They'll stay in one place inside one bracket. Do you understand? So they have lengths that are different again. Okay, let's continue. Determining the true length of each member is important to ensure quality and accuracy of the measurement. There are two methods of determining the true length of these members. Graphically, this scale drawing. In this question, what it was requiring, it wanted us to draw. So that is graphically scale drawing, and by calculation trigonometrically, you will see it in N5 again when you use calculations to get this instead of draw. And then for this level, only the graphical method will be used. So they are confirming what here will only be drawing again. So example 4.14 shows an example of graphical method of determining the true length of truss members. The drawing is also labeled to show how the measurements of each item is obtained. So that drawing there that you see is just a drawing that shows you what, length of queen post starts from here up until there. This is a queen post, it starts from here up until there, okay? So the diagram we're talking about is this one. Yeah, Chololamo? Yeah, so that's the diagram there. So trusses, you need to know which is a truss, which one is a truss. This one falls under a truss, this one doesn't. Again. Okay, so trusses, we have queen post, we have queen post, we have king post. What else? Diagonal struts. One has, I do not say strut. Diagonal strut, then tie beam, rafter. What else? The village. Where are going? Where are you going? Are they complete?
Yeah.
Tie beam is this one. Tie beam is that long one. Again, it's only one. It's this one. It's a long one. Here is an example of a tie beam. Again, that one is a half thrust. So someone might say, no, just because this is a half thrust, I have two tie beams. No, that's not how we do it. Tie beam K1 is just a long timber plank. It's like this one. I can buy one of it straight. It's just one. Okay? So that's a tie beam. And then we have what is called a king post. King post, it's only one. It's in the middle. It's the one that holds this side and also that side. So right here, so okay. This is your gable, and then this timber that is holding these two into place, it's called the king post. Again, okay? This one, it's a king post, and then we have something like this. What is this called? Diagonal strut. Again, then after the diagonal strut, you have what? A queen post. Queen post. So queen post, it's two. Diagonal strut, it's two. King post, it's one. Again, and then the tie beam is also one. Then our rafter, here raftering again. And then what else? It's complete. Alright. So please be able to identify the trusses. So these are our trusses. And then the length. Length. We have not exceeding 2,4, right? And then exceeding 2,4, not exceeding what? Not exceeding 3,6. Then exceeding 3,6, not exceeding 6,6. Is it 6,6? Yes. Okay, so those are our lengths. Not exceeding 2,4, exceeding 2,4, not exceeding 3,6, exceeding 3,6, not exceeding 6,6. What time is it? So now for the trusses. On the specification, there is a bullet. I think it's bullet number 2. I'm not sure. Just check on the specification. There's a bullet that says trusses are spaced at 750 centers, right? 750 centers. So you always say this kind of specification again. As long as you are trusses spaced at, make this your best friend. You're going to use it again. So trusses, we need to calculate what? What's the first thing that we need to calculate under trusses? The number of trusses, I guess. So number of our trusses, what are we going to do? How are we going to calculate it? What do you remember? First things first, our trusses, are we going to say use internal length or external length?
Internal.
Internal, right? We're going to take 6,440 that starts at the bottom until here again. Then we subtract 100. We want internally, just we need to exclude the walls again. And we can't say 6,440 minus 12 to 20. What about this 100? You understand? 6,440 actually includes less than 100. 6,440 minus 100, then minus 2 of 220. What are we getting? 5,900. Then you take this 5,900 that you got. Okay, another thing, the last time, do you remember that time we did year 2024? I think 2024 November. And then I think it was like this diagram was like this. And then you guys used the short one again. So keep in your mind for your trusses again, you use the longest side. Irregardless of how it is seated, you use the longest side, okay? So Limo, we're going to use 6,440, then you subtract 100 minus 12 to 20, you got 5.9 again. Then we divide by the centers, the spacings again. So they said it's 750, so divide by 750, what are we getting? You're getting 7,87, then you need to round that off, it's 8 again. So this is 8, our answer we got 8. And then how many fingers do I have? 5. 1, 2, 3, 4, 5, 6. 5 fingers, 6 spaces. So here we have 8 classes, 9 spaces. Again, the number that you're going to get when you calculate, again, you're going to take the longest side. You keep in mind, oh, I want internal length. Again, if I want internal length, I'm going to take my length and then I subtract my walls. Then I divide by what? The spacing, the center to center on the specification again. And in this case, it's 750. Then I round off my number that I got. We got 8 again. Then it is, you remember your fingers. You just say, oh, I have 5 fingers, but 6 spaces. I have 8 classes, but 9 spaces again. So you always add 1 here again. Always add 1. This is constant. Always add 1. And then what do we have? 9 again. So it means that how many number of classes do we have? 9 classes. Good. Good. Okay, okay, let me not erase. And then now what are we going to do? Categorize our lengths again. We are going to start with which one? You open a bracket here. Which one are we going to start with? Not exceeding 2,4 again. So here, these are classes that are not exceeding 2,4. Then we look at the diagram that we have drawn, okay? The diagram that you would have drawn in the Excel. So this is our diagram. And then, what is this? Diagonal strut. So if this is a diagonal strut, it's 1035 again. Does it fall under not exceeding 2,4? 2,4 is 2,400 again. So 1,000 is not exceeding 2,400 again. So here you're going to put a dash and say this is a diagonal strut. And then the length is 1, what is 1035? It's 1040, right? Then you divide by 1,000, it's 1,04. So that is how we do it, our diagonal strut. And then after writing your diagonal strut, how many diagonal struts do you have? Remember that this is a half truss. When you take off, you don't exactly focus on your half truss again. Or if you focus on your half truss, keep in mind, or no, I don't deal with a half truss, I deal with a full truss. So let us look at our full truss. This is a diagonal strut, this is also a diagonal strut. How many diagonal struts do we have there? So you multiply. You take your truss, you write down the length. You multiply by how many are they? If it's a diagonal strut, it's 2 again. Then you multiply by the number of trusses. Then you underline. You come to the next one. Let's check. It's 703. What is this?
This is queen post.
Queen post. So you come here. Okay, sorry. Our queen post, is it exceeding 2,400?
No.
So it means it falls under not exceeding 2,4, right? So this is a queen post. Our queen post is 703. 703 is 0, 0,70. How many queen posts do you have? 1, 2. You have 2, then you multiply by the number of trusses. So you underline. Do you understand?
Yeah.
We go to the next one. What is this? What's this? Does it exceed 2,4? No. So king post. Now I will have to erase. Queen post, what's the length? 1145, it's 1, 1, 5. Again, it's 1150 when you round off. So it's 1,15. How many king posts do we have? 1. This is the king post, it's only 1 again. This is your king post, it's only 1. Even if you were to continue writing a full class, you will find out that it's 1. So you don't write that 1, then you multiply by the number of trusses, which is 9. What else what else is falling under 2,4? The one that's not exceeding 2,4. Type in. And then it's done and you will complete.
Yes.
Okay, we've completed the not exceeding 2,4. Now we go to exceeding 2,4, not exceeding 3,6. Which class is exceeding 2,4 but not exceeding 3,6? Rough. This is our rafter. What's the size of our rafter? 2924. It's exceeding 2400. So rafter, what's the size? It's 2 comma 2924 is 2928 again. So it's 2,92. How many rafters do you have? 1, 2 again. You have 2, then you multiply by the number of trusses, which is 9 again. Then what else is falling under not exceeding 2,4, not exceeding 3,6? We only have one thing left. Okay, that's 5 trusses. So it's the tie beam. A tie beam, let us look at this diagram. A tie beam starts in the middle of your wall again. In the middle. This is where it starts. So this one, I'll show our tie beam. It starts in the middle. This is where it starts. And here you have 1866 again. So what you're going to do when you want the tie beam, it's more like, okay, you have 3732 again. And really, this 3732, it is including the walls. What you're going to do, your tie beam starts half. So you can say 3732 minus 110 this side minus 110 that side again. Beautiful, guys. 3732 minus 2 of 110. Oh, 3512. So it's not exceeding 3,6 again. Or you can say, let's check. We have 1866 and it's including the wall again. So you can say 1866 minus 110. What is 1866 minus 110? 1866 minus 110. 1756. Then multiply this by 2. I get it's by 2 because 1866 here, let's have multiply by 2. 3512. Now it is the same answer. 3512. So it's 3,51. So this is 3. So this is 3,51. Then we multiply by 153. 9. Because it's only 1, just like the king post again. So there we have it. And then under your trusses, you close this bracket again. You close this bracket. Under your trusses, you're going to say splay cards to the rafters. When a rafter, this is the rafter again. A rafter at the end, it is cut like this. Like, I know what it's cut. By cut, at the ends, they cut it. So we call those play cards again. So it's also part of the trusses. We include it as part of the trusses again. But you close that bracket, then you open a bracket and you say splay cards to the rafters again. How many splay cards do we have? 2. It's 1, 2 again. So open a bracket and say splay cards to the rafters, then say it's 2. And then this 2, are we going to multiply it by the number of trusses? Why? Are we going to multiply it by the number of trusses? We are going to multiply it by the number of trusses. So it's going to be 2, then you multiply it by 9. Again, I said it's part of the trusses. You include it as part of the trusses, so multiply it by 9. And then are we done with the trusses? We are still there. We are still there. There is one more bracket left, which is called the sprockets. It's called the sprockets. Okay, for now, again, let us open that question paper of 20, I think it's 2024. Let's go to 2024. Yeah, let's go to that question paper 2024 and then it's classwork. We'll finish this tomorrow.